We have to find the volume of a solid when the region R is rotated about the x-axis. So it's going to be rotated about the x-axis like this, and this is the region bounded by the two functions. Alright, so we're going to see a demo first and then come back to this problem. So what we have here is the region R, and this region R is going to be rotated about the x-axis, and then this blue area will form the solid. So as I'm going to move this, so we can see that the two curves move to form the solid, and we have the solid, and it is approximated by discs, and this is a washer, and then each is going to be a washer. So we're going to get an expression for one washer. Washer is a disc with a hole in the middle, so we are going to get an expression for one washer, and then continuously add the volume of the washer from the left end to the right end. So we're going to draw the washer here. So we're going to choose a point x comma y on the upper curve, and then there is a corresponding point on the lower curve. So we have this. Before that, let's draw the reflection of the region R. So this is the volume of revolution. In that, we're going to draw one washer. Okay, so it's kind of a washer, which is like two concentric circles with a very thin width. So we're going to find, write an expression for the volume of the washer and continuously add it from 0 to 1. So volume equal to, continuously add in the direction of x. X goes starting from 0 to 1. We're going to add the volume of the washer, which is pi r squared minus r squared times the extremely small width of the washer is going to be dx. We need to identify the capital R and small r. So this whole thing is the capital R. This part is the capital R, and this part is the small r. So we have pi, and capital R is the y value of the upper function. We'll write the y value of the upper function minus the small r is the y value of the lower function with respect to x. So I'm going to rewrite the y value of the upper function is the square root function square. It's going to be square root function, so square root function square minus the lower function is a y equal to x squared, so which is x squared the square dx. So we're going to integrate it from 0 to 1. So pulling the pi outside, 0 to 1, this will become x minus x4 dx. This will become pi. Integral of x will become x squared over 2. Integral x4 will become x pi over 5. Evaluated from 0 to 1, which is going to be pi 1 by 2 minus 1 by 5, which is going to be pi 3 over 10, 3 pi over 10.